What I'm going to be talking about is federated searching with a natural language interface into a database. Now, this subject is not exactly new. It's basically been around, or it was initially defined in about 1984 by Mazur, who basically said it was the properties of a global model consisting of n local information retrieval systems, and he based his on a thesaurus. So from that sort of rather convoluted description, federated searching is basically the concept of searching multiple repositories through a single interface. And the right one. So why is it important? Well, most organizations have a large number of repositories. Some of these could be spanking brand new. Some of these could be pretty ancient. Now, for a large organization, if they're going to get a better understanding of their customer, what their customer needs are, what their customers' usages are, they're going to have to try and collect all this information. If we start talking about utilities or banks, customers' usage could go back many years, could go back across multiple different repositories. So how can an organization in fact harvest that information? And with the Google effect as well, and this is a term that I've been sort of spouting about or talking about for at least 10 years, and it's basically the term where we can search vast quantities of information and get back a result pretty quickly. Google have got petabytes of data, and when we tab a search in, we expect to get a result back within some sort of sub 5 seconds. Anything longer than that and we start getting bored. So let's go back a slide. One of the problems with federated searching has basically been the fact when we're talking about disparate repositories, we're talking about the lack of interoperability between those repositories. There have been a number of studies carried out in the US. We've had federated search engines installed in a number of university libraries in the US. The Sam Houston is one, and there was also the New Mexico State University Library. These instances basically failed. And part of the reason they failed was that users, first of all, lack the confidence that the search was actually federated, that they were actually able to get results based on all the repositories that were held or being used by the library. There was also issues with performance. Some of these federated search engines were taking far too long to bring back results. So a lot of libraries have looked into this and have basically turned around and said, nah, we can't do it. It's too difficult. Now, yeah, we can go back to Google and basically say, well, Google can do it, and yes, they can. And they're taking, and I'm going to talk about that in a bit, but they're sort of taking a very similar approach to the one that I'm proposing. It's just that the approach I'm proposing is, I think, more flexible than the one that is being used by Google. Now, most indexing engines basically create an index file that gets searched. So when you index something, you actually create, in effect, a new repository or a new data blob. So same with federated searching. And what I'm proposing within my research is the creation of a number of index files. So we have an index file per repository. I can create within that index file, I can create in effect, a pseudo database structure. So I can become repository agnostic or database agnostic. I don't have to know in advance what tables I have got within my database. I don't really need to know whether I'm looking at an Oracle database, or whether I'm looking at a MySQL database, or whether I'm looking at a Microsoft database. I can basically create the index based on the tables that are there. And what I can then do is, at this point, I can take the natural language query. Give me the details of everyone called Smith. Now, that Smith's information may be held in about 5 different databases. Do I naturally need to know that it could be the surname Smith when I'm doing my translation from a natural language query into an SQL query? Because my index file tells me. My index file tells me, at this point, what table I'm going to have to search. I'm going to have to search at this point customers, because my index file tells me so. It tells me that I've got a surname of Smith, or an attribute of Smith, within that within the database. So, okay, let me search for Smith at this point. So I'm creating, using an index file, or a bag of words if we start talking about natural language, I'm creating an SQL query straight from a natural language query. Now, the way Google do it is they, in effect, create a series of templates. So using a series of templates, they take the natural language query and map that to an SQL query that can then be used to retrieve the information back to you. I'm saying, no, I don't want to do that. I want to use an index file. So I'm taking a slightly different approach. I'm not overlaying massive amounts of templates. I'm reducing the complexity through the use of an index file, rather than building up a very complex template structure. And I'm hoping, with the aid of machine learning, to refine the process of creating the SQL query based on the index file. Now, the next thing to look at, and the final thing, is to divide and conquer. When we start talking about federated searching, we start talking about multiple databases, multiple repositories. As I said at the beginning, one of the common problems that has arisen with existing or previous attempts at creating federated searching is the fact that users did not believe that all the repositories were being searched. By taking an agent-based approach, I can create an agent for each repository that I want to search. So I can then, in effect, label up which results are coming back from which repositories. And I have got more faith that all my repositories are being searched. So, I'd like to thank you. Any questions?